Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the evidences of even mechanism. So there are 4 evidences with their suitable example. We have learned that evidences of even mechanism. So the point, what is the point we are discussing today? Today we are going to discuss about the orientation of even mechanism, orientation and the reactivity of this particular discussion. Here the orientation of even mechanism, the elimination by even always show strong CH orientation. That is, when more than one alkene can be formed, the highly branched or more stable alkene is the preferred product as we know. And there are 2 aspects about even reactivity and the orientation. These are the 2 aspects we are going to discuss in this case. Number first aspect is a reactivity and number second one is a orientation. And now first one, how far the substrate react, that is the reactivity is determined by the rate determining step, means slow step, that is slow step, and B, which alkene is produced as a major product, that is the orientation is clearly determined by the which beta hydrogen is lost faster from the carbocation in step number 2. Then let us consider the reaction of 2-pentyl tosylate with N-butyl alcohol. Let us see here. We are going to consider one of the example, this one, CH3, then CH2, then CH, then OTS, then I think not this one, pentyl we are going to consider, one more CH2 and then CH, OTS, then CH3. The name of this compound is a 2-tosyl pentylate, right? 2-tosylate pentane. So this is a compound. Now in a E1, and this is treated with N-butyl alcohol, NBuOH. And that first step, as we know that it is a slow step, means rate determining step. In first step, what is happening there? There is a loss of living group, and as we know that tosyl group is a very good living group, and when it leaves, you are going to get this one, CH3, then CH2, another one, CH2, and then CH, and the CH3 positive charge comes on this carbon atom, right? When the positive charge comes on this carbon atom, what is the next thing happening over there? There will be a rearrangement, or there is a 3 products are formed. Now how these 3 products are formed here? Let us see these 3 products over there. Now when proton is lost from here, you are going to get this type of the product, carbon-carbon double bond, one over there. Here you can write this CH2 and CH3, another one methyl group I am writing over there, and one of the hydrogen atom and another hydrogen atom. This product is called as a trans product, right? This is a trans product, and trans product is obtained near about as a, I think percentage of that is a 70%. Trans product we are getting as a 70%, and one more product we are getting, this carbon-carbon double bond. Then I am putting this group, this CH3. The here trans means what? The similar group are on the opposite side of the carbon-carbon double bond is called as a trans. Now the similar group, hydrogen and another hydrogen, they are on the same side, that is known as a cis isomer. This is a cis isomer, or what is this? We are getting 11%. And when these two products, they are according to as a CH-5 rule, right? These two products is obtained according to as a CH-5 because they are the more substituted. These two are geometrical isomer in terms of the stereochemistry. If you talk this one, this is about the geometrical isomer, and this one finally when the hydrogen is lost from here, here you can call it as a beta dash, and this one is a beta. Here is a beta dash hydrogen loss, here is a beta hydrogen. When beta hydrogen will be lost, you are going to get here CH3, CH2, this CH2, then CH double bond CH2, and this we are getting near about is a, how much is a 81%, right here, and remaining one is a 90% only. 90% of the product, and the IUPAC name of this compound is a 1-pentene over there. So in this way we have got three products are there. Among three products, these are according to as a this CH-5 elimination, and this will be the Hofmann product or Hofmann elimination. This is about the Hofmann elimination reaction. And now why this so? Because when the transition state is formed, in this case when that OTS, or what we can call it as a BR, that favor the even mechanism carbocations are there, and the transition state is a less crowded transition state. Favor the Hofmann elimination reaction, and more crowded transition state that favor the CH-5 elimination reaction. So in this way, which we have seen as a orientation and the reactivity, why this one we are getting as a major, this is a orientation, and this we are getting in a minor case, that is a what we can call it as a minor in case. So this is about the orientation. And the now the final point remaining in this chapter is this one. Let us see that one. What is that? E2 versus, that is a E2 versus E1 mechanism, right? So last point remaining is a elimination E2 versus E1. Elimination E2 versus E1. E2 versus E1, right? And as we know that as the when the E2 reaction takes place or E1 reaction takes place, that is depend upon the two factors are there. Number one, the substrate of the structure of the substrate, and then second one is the nature of the base used. And then as the structure of the substrate, what kind of the structure of the substrate? If the structure of the substrate is a tertiary alkyl halide, that both favor the E1 mechanism as well as E2 mechanism. But if the tertiary carbocations, because in case of the tertiary halide, when the departure of the leaving group departs, and there are the plus R alkyl groups are there, alkyl group exerts as a plus R inductive effect, and they are increasing the what we can call it as a stability of that alkene, and due to this reason the reactivity of this E1 as well as E2 is increases if there is a increases from primary to secondary to tertiary halides in the same manner. But here the substrate is increases, then and then primary, secondary and the tertiary, both the reaction goes on increasing. But in case of the E1, tertiary are there is a formation of the carbocation in the first step, and therefore more the carbocation stable that favor the E2 mechanism, right? And for E1, for E2, there is a simultaneous transition states are there, and that's occurring, and we are getting as that type of the compound over there. And second one is the nature of base use. If the nature of that bulkiness of, or it depend upon the concentration as well as nature of that base, and that E1 mechanism as well as E2 mechanism is proceeding through the base use over there. But that base, in case of the that base use in a E2 mechanism, that depend upon the concentration as well as nature of that base. Nature means whether it is a strong base or the weak base. Depending upon that, we that affect the rate of the E2 reaction. But base, in case of the E1 mechanism, it is independent on the nature as well as concentration of the base used in the in E1 mechanism. It does not depend upon the E2. So in this way, if that base use, whether it is strong or weak, that does not affect the E2 reaction, E1 reaction, because the role of base used there for the abstraction of the beta. So in this way, we have what we can call it as this is about the elimination E2 versus E1. And the last point remaining in this chapter, that is E1 mechanism and the E2 mechanism. Similar to as a SN1 and the SN2, we have divided, we have distinguished these two reactions, E1 and the, here we can call it as a E2 mechanism, and here will be the E1 mechanism. As we know that first one, if you talk about the kinetic study, it is a bimolecular reaction, it is a unimolecular reaction. Two indicate as a bimolecular, one indicate as a unimolecular reaction. And this one proceeding through single step, this one proceeding via two steps are there. Here the transition state is formed, that it is a concerted reaction, because bond breaking and bond making are taking place simultaneously. But in this case, what is that? There is a formation of the carbocation in that, and now this, it depend upon the nature of the base used, because this affect the rate of reaction. If in a case of the E1, it does not depend upon the rate of the reaction. And what we can call it as this according to as the orientation of E2 reaction according to as a CH-5 rule. I think with this we have seen all the point in a E2 elimination reaction. What are the important point, or what are the important question as far as the exam point of view is concerned? Now 1 mark question, what type of the 1 mark question may appear? State the CH-5 rule, or maybe state the Hofmann rule, or what is the kinetic isotopic effect, or suppose as the size of living group increases, the percentage of what we can call it as a Hofmann increases, explain, or as the size of living group increases, the percentage of formation of the CH rule decreases. So that type of the question may appear for exam. And one more 5 mark important question is there. What is E2 mechanism? Give the evidences of E2 mechanism. And second important 5 mark question, what is E1 mechanism? Give the evidences of E1 mechanism. That 2 questions are very important as per as exam point of view is concerned. And the last one, write a notes on. Write a notes on maybe as a write the notes on E1 CB mechanism. And as we know that E1 CB mechanism means what? What is that? E1 CB mechanism, the elimination proceeding through conjugate base. You have to explain with that example we already seen. And 1 mark question may, what is kinetic isotopic effect? So that type of the question may appear in the exam. So remember, then there will be a predict the product depending upon they will give the product, and from that you can predict the product. I think with this we have completed as a chapter number 5, the last chapter remaining in this semester, because we are studying as a semester number 3 for T.Y.B.Sc. So last chapter, the name of that last chapter is aromatic, electrophilic and nucleophilic reaction. Aromatic, electrophilic and nucleophilic reaction, that we will see tomorrow. Let us stop today here. Have a nice day. Thank you.